Okay, students, so we'll move on to the next topic, that is string length mod k problems with relational operators. Okay, so in previous lecture, we discussed what is mod k problem. Fine. For finding the transition, we are using a formula called delta of qi comma a will be equal to delta of q of I plus 1 mod k, right? The same formula we need to use over here, fine, but uh, like the length of the word should be divided by some value, like example, length of w mod 3 if it is available. Okay, then you may be looking for some reminder. Okay, reminder may be 0, reminder you may be expecting apart from 0, like 1 comma 2 also. Fine. So whatever may be the condition, so what we do for finding the transition, we are using that particular formula. Fine. So to find that, like q naught, if it is receiving some alphabet, whether it is going to change its state to any other new state or not. Clear? Okay. So now, in this case, instead of having such kind of only one mod operation, we'll be having two different mod operations over here. Okay. So when we go for the problem, you can have better knowledge about this. There will be two conditions. Okay. Like length of w mod 3 should be equal to length of w mod 2. Okay. So this may be the question. Okay. Given in your exam. Fine. So now we'll see, like if you are having such kind of relational operators between two different machines, okay, then how we can solve? Yeah, the same formula, okay, the same procedure is getting involved over here, okay, but the first condition we need to solve it separate, and second condition we need to solve it separate. Then we need to go for merging them. Clear? Okay, we got some procedure. That's it. We don't have any formula or anything. Okay, we have some procedure. That's it. Okay. So now let us see what is general method to solve string length mod k problems with relational operators. Okay. The general method is shown below. The step number 1, solve the string length mod k problem connected by a relational operator as two independent problems as in previous section. Okay, how we discussed in case of mod k problem, like individually how we are solving, right? Okay, like that here, two different conditions are available. So first condition should be considered as the first machine and second condition should be considered as second machine. Okay, you need to solve them separately. Okay, fine. Feel it. You have done with the solving both the machines. Okay, so now we'll come for step number 2. Now this states Q of combined machine. Remember, here we are calling like first condition M1 and second condition M2. Clear? The states which are involved in machine number 1, okay, we are calling it as Q1, and state which are involved in machine number 2, we are representing it by Q2 exactly. But later, after combining them, we need to generate Q and M. Okay, after generating, we need to find, okay, what is the combined state. Okay, so here we are solving it separate, right? Okay, later it should be combined. Okay, so that it should be considered as a like Q, okay, and M exactly. So now we'll see how we can combine them. Now the state Q of combined machine M that accepts a given string W is obtained by taking a cross product of Q1 and Q2 as shown below. What we need to do, the states of machine number 1 should be multiplied with cross multiplied with states of machine number 2. That's it. Okay, so whatever the states we are generating, the combination of Q1 and Q2, so that pair we are calling it as the combined version of Q exactly. Clear? Okay, where Q1 and Q2 are the states of machine M1 and M2 respectively. Later, step number 3, after obtaining the states, okay, obtain the transition delta of combined machine using the transition delta 1 and delta 2 of machine M1 and M2 respectively. That is, see here how we are writing this kind of transition. Just observe delta of P comma Q. Okay, so this is what the state, combined state, observe it carefully. P is from machine M1 and Q is from machine M2 exactly. This is what after we are getting the cross product. Okay, after cross product, the states will be looking like this. Okay, P comma Q. Okay, one from M1 and one from M2 exactly. Okay, if input alphabet is A, then how to process them? See here. Okay, how we are elaborating it. P belong to machine number 1. That's why delta 1 of P comma A. Okay, we need to check what exactly the transition is available from state number P on receiving A. Okay, in machine number 1. Okay, then same delta 2. Okay, we need to check for machine number 2 where we are having a state called as a Q on receiving alphabet called as A, what will be the return value? Okay, the outcome, whatever we are getting, so that will be the resultant. Clear? Okay, using the relation using the relation, okay, we can identify the final state. Okay, that I will tell you later, like how we can identify the final states. Okay, when we solve the problem, we can have a better knowledge about it. Because here in this explanation, we don't have a like pattern of question over here. Okay, so now, so here we got the first question. Obtain a DFA to accept a string W. W is what the string, satisfying the following condition. Okay, length of W, if you divide it by 3, the remainder, whatever you are getting, remember, it should be either greater than or equal to the length of W if you are dividing it by 2 exactly. Okay, means you are having one alphabet pattern. See what is the like string alphabet available. You can observe sigma is equal to A exactly. Okay, sigma is equal to A exactly. So if the alphabet patterns are like continuous 4A's, continuous 4A's. So 4A length will be equal to what? 4 exactly, right? Okay. 4 divided by 3, what is the remainder we are getting? 1 exactly. So here you are getting 1. Okay. So here you are getting 1. Okay. So same alphabet, what is the length? 4 exactly. 4 mod 2, what is the result you are getting? 0 exactly. Okay. So this kind of condition or this kind of alphabet is satisfying the condition that greater than or equal to, right? Okay. 1 is greater than 0 exactly. Then continuous 4A should be accepted by the DFA what you are going to design. Yeah. Okay. Then later, in case of 3A's, observe it carefully. If 3A's we are having, length of W will be equal to 3. 3 divided by 3, result will be what? 0 exactly. So length of W is 3. 3 mod 2 will be what? 3 mod 2 will be what? 1 exactly. Okay. Whether you are satisfying this condition? No, actually 1 is 0 is less than 1 exactly. So 3A if I provide, it should be rejected. Yeah. Okay. I hope you got some idea regarding the question. Okay, fine. So now, what we need to do here, we got two different conditions. Okay, one is for mod 3 and one is for mod 2 exactly. Right? Okay. So we'll consider this as machine number 1 and we'll consider this as machine number 2. Okay. So the states which are all involved in this particular machine number 1, we are representing it by Q1. The state which are all involved in machine number 2 will be represented by Q2 exactly. I hope you don't have doubt till now. Okay. So this is what we call it as a relational operator. Here, greater than or equal to, less than or equal to, or sometimes equal to, or sometimes not equal to. Yeah. Okay. So in the above problem, we have both like length of W mod 3 and length of W mod 2. So we need to construct two machine M1 and M2. Okay, one like M2, one which represent to length of W mod 3 and another represents for mod 2 exactly. Okay. So this is what for machine number 1 and this is for machine number 2 exactly. Okay. So don't worry about the final state. This is not the right time to decide which one will be the final state because we are creating the DFA for like individual condition also. Okay, later we need to merge. After merging itself, we need to go for deciding which one will be the final state. Okay, so just consider, see mod 3 we are having, right? Okay, so k minus 1 states will be available. Okay, what is the k value? 3 exactly, right? What is the k value? 3 exactly. Okay, the possible reminders will be what? 0, 1, 2 exactly, right? So 0, 1, 2 exactly. What is the input alphabet we are getting? What is the input alphabet we are getting? A exactly. So that's why we are writing the machine in this format exactly. Okay, like 0 on receiving A, it will go for 1, 1 on receiving A, it will go for 2, 2 on receiving A, it will be coming for 0 exactly. Okay, mod 3, here we don't have a condition like whether it should be equal to 0 or whether it is not equal to 0. But in this condition, what we are feeling is, here we are having equal to 0. Clear? You may ask like why we are writing like this. Okay, so after 2, I can provide a self loop, or for 1, I can provide a self loop. Okay, why we are providing it is like 0 to 1, 1 to 2 to 2, 0 exactly. We are feeling that it is equal to 0. Okay, it is equal to 0. Okay, if this is the case, then 0 will become the final state, right? Here we don't have any condition. Okay, because of that, we are feeling that 0 we will consider as a final state. Because of this, we are writing like this. Here also, just observe. Okay, mod 2 we are having, right? Mod 2 we are having. If it is equal to 0, means whenever we are getting even number of A's, it should be accepted. Because of that, here on receiving A, 0 to 1, on receiving again one more A, it will be coming for 0 exactly. Okay, so if it is equal to 0, then 0 will be the final state exactly. By assuming it as 0, we are considering or we are designing these two machines over here. Okay, don't consider it as 0 for time being, because if you're considering it as 0, then you need to write it as final state. Just assume, okay, just assume it as both are equal to 0 over here. Okay, fine. So this is what the two machines we can design it for these two particular condition. Okay, so then Q1 represents the states of machine number 1. How many states are there? 3. What are those? 0, 1, 2 exactly. 0, 1, 2 exactly. Then state number Q2, okay, we'll be having only two states, 0 and 1 exactly. Then draw the transition function delta 1. So 0 on receiving A, it will be going for 1. 1 on receiving A, it will be going for 2. 2 on receiving A, it will be coming for 0 exactly. So this is for the transition of machine M1 exactly. So this will be the transition for M2. Okay. So I hope you don't have doubt till now. Okay. This is very simple how we were like solving the mod K problems in previous lecture. Okay, the same variety we are using over here. Here, only thing is what, like we are not deciding the final state. That's it. Okay, the benefit of using mod K problems are what, like we can initially identify what will be the final state. Okay, but here for time being, what we are doing is we are avoiding the like decision of final state. That's it. Okay, so that is what the only thing is missing over here. Then we'll go for this relational operator kind of problem now. Like this is what the mod K variety it is. Okay, now we need to merge it, or we need to travel for the relational operators now. Okay, fine. We'll see this, how we can solve the relational operation between these two machines. Okay, so in previous slide, we decided like what will be the transition for M1 and what will be the transition for M2. Now we need to go for combining them. Okay, so now the machine M1 accepts a string W whose length is divisible by 3. Okay, that is mod 3. Then the machine M2 accepts a string W whose length is divisible by 2 exactly. That is the length of W mod 2 exactly. Okay, now the states Q of combined machine M that accepts a given string W can be obtained by taking the cross product of Q1 and Q2, okay, as shown below. Q1 first state is what? 0. Okay, what are the possible states of Q2? 0, 1. Okay, so 0 into 0, 0, 0 we are getting. Then 0 into 1, 0, 1 here. Okay, for your understanding sake, for Q1 we are having 0, 1 and 2, and Q2 we are having 0 and 1. So 0 into 0, 0, 0 we are writing. Then 0 into 1, 0, 1 we are writing. Then later 1, 0, 1, 1. Here 1, 0 and 1, 1. Then at last 0, 2 and 2, 1. 2, 0 and 2, 0 and 2, 1 exactly. Okay, so these are the possible states. Okay, what we can generate after merging the machine number 1 and machine number 2. Okay, so now the initial state like 0, 0, we are considering it as a start state. Okay, in the both the machine 0 was the start state. Okay, so that's why we are obviously like 0, 0 will be the considering it as initial state or as a start state. Okay, with state 0, 0 is the start state. The transition on each of the pair x, y can be obtained as shown below. Okay, so the transition, okay, from the first slide explanation regarding how we can solve this. Okay, the formula we are using over here, or as the pattern we are using over here. See here, if we are having delta of p comma q on receiving A, this form, okay, then it should be written as what? Delta 1 of p comma A, delta 2 of q comma A exactly. Okay, so now we'll see. We'll consider the first state, that is 0, 1. We'll consider the first state 0, 1. Delta of 0, 1. Delta of 0, 1, comma A. Okay, so this is what the input alphabet and this is what the state. Okay, how it should be processed? Say delta 1 of 0 from the machine number 1, comma 0, sorry, comma A, and later delta 2 of 0, comma A. Okay, like this we need to split, because in the place of P we have 0 and in the place of Q we are having 0 exactly. Then you may ask like how we are writing it as 1, 1. Okay, what you need to do, you need to observe the previous slide. You need to observe the previous slide exactly. Okay, let me show the previous slide. Wait a second. Okay, you can observe the 0 on receiving A, what it is performing, it is changing its state to 1 exactly. Here also 0 on receiving A, it will be changing its state to 1 exactly, right? So because of that, 0 on receiving A in state number machine 1, okay, so we are writing it as 1 over here. What is the change of state? Okay, we are performing for the 0. What is the change of state performing for the 0 in case of delta 2? Okay, both we need to write over here, 1 comma 0, 1 comma 0 we need to write. Like that, what one new state we got, right? 1 comma 0. Okay, for this we need to find the transition. Okay, so in the same pattern, delta of 1 comma 1 bracket close comma A exactly, then delta of delta 1 of 1 comma A, then delta 2 of 1 comma A. Okay, then what we need to do? See, we need to consider this state number 1. Okay, state number 1 on receiving A, it will be changing to 2 exactly. Here, 1 to 0 exactly, right? So the outcome will be 2 comma 0. Then we need to find the transition for 2 comma 0. Okay, on receiving A. In case of first machine, 2 comma A if you are having, then it is changing its state to 0 exactly. Because of that 0 you are getting. Then in case of like state number machine number 2, 0 is the state on receiving A, it will be changing to 1 exactly. Because of this 0 comma 1 we are writing. Like this we need to find the transition for each and every alphabet, each and every states exactly. See, 0 comma 0 we found, then later 1 comma 1 we found, 2 comma 1, 2 comma 0 we found, 0 comma 1, 1 comma 0 and 2 comma 1. Okay, see 1, 2, 3, 4, 5, 6. How many states we got over here? 1, 2, 3, 4, 5, 6. Okay, so finally we are done with finding the transition for each and every state. Okay, and these are the results we got. Okay, so now in this cycle itself we need to write it. Okay, in this cycle itself we need to write the transition diagram. First, what was the state? 0 comma 0. So 0 comma 0 we are writing. So after that, what on receiving A, where it is going, it will be going for 1 comma 1, right? Okay, the next state will be 1 comma 1. Then 1 comma 1 on receiving A, 2 comma 0 it is. So 2 comma 0 we are writing. Then 2 comma 0 on receiving A, 0 comma 1 exactly. Because of that 0 comma 1 we are writing. Then 0 comma 1 on receiving A, 1 comma 0. So 1 comma right, 1 comma 0 we are writing. Okay. Then later 1 comma 0 on receiving A, it will be going for 2 comma 1. So 2 comma 1 we are writing. At last 2 comma 1 on receiving A, it will change its state to 0 comma 0 exactly. So we will be having a reverse loop of A to 0 comma 0 exactly. Okay, so this is how we are finding the transition diagram for this particular question. Okay, now the only thing is what we need to decide the final state. How to decide the final state? The question. Okay, so now observe what is the condition we are having. Length of W mod 3 should be greater than or equal to W. Okay, so now like we are considering it as X and Y pair exactly. The pair X comma Y such that X greater than or equal to Y are the final states. Okay, means when you are considering the state name, observe it, 0 comma 0, 1 comma 1, 2 comma 0, 0 comma 1, 1 comma 0, 2 comma 1, right? So consider it as a X and it as Y. Okay, first place should be considered as X, second place should be considered as Y exactly. Okay, so now the states which are all satisfying X greater than or equal to Y condition, everyone will be the final state. Okay, so here X can be greater than or equal to Y. 0 comma 0 equal to condition it is, 1 comma 1 equal to condition it is, 2 comma 0 what it is, greater than condition, satisfied. But 0 comma 1, no, it is not satisfying because the X is less than Y exactly, right? So this cannot be a final state. Then 1 comma 0, 2 comma 1 exactly. So except 0 comma 1, okay, see here there is some correction. It should be like 1 comma 0 exactly. Somebody has overrated it as 0 comma 1. It is wrong exactly. Okay, so what is there in textbook? It is perfect. Okay, 1 comma 0 it should be. It is not 0 comma 1. Okay, so these are all will be the final states. Okay, except 0 comma 1, rest of all the states are called as final state because they are satisfying the condition X greater than or equal to Y exactly. Okay, so if that is the case, then the final state or the final DFA what we can write for the like relational operation mod K problem was okay 0 comma 0, 1 comma 1, 2 comma 0. 1, 0, 2, 0. So all will be the final state except 0, 1. Why? Because x is, we are considering 0 as x and 1 as y. X is not greater than or equal to 1 exactly because of this. Okay. I hope you don't have doubt regarding this question. Okay. So I will move on to the next question, okay, which is much similar. Like the procedure will be same, okay, how we solved in the previous question. Okay, here we got one more condition, that's it, nothing else. Fine. Obtain a DFA to accept the following language L, W, such that like length of W mod 3 greater than or equal to W mod 2 exactly. Okay, so here only difference is what? Instead of having only one alphabet, we are having two. A comma B you are having. There you had only A. Okay. So the same condition, length of W mod 3 should be greater than or equal to the length of W mod 2. Okay. So this is what the result we are going to get. Okay. See, directly we cannot write this. You need to solve the problem according to the steps. What you need to do, you need to consider it as machine number 1 and machine number 2. Like consider this equation as equal to 0 and this also equal to 0. According to that, design the DFA. Okay. Then later go for the cross product. Okay. Generate some states. Fine. Like try to find the transition of delta 1 and delta 2. Then later decide the final state. Okay, so after deciding that, okay, we got this particular gesture of a DFA. So this in the previous one, whatever we had, the same one we have for the first half. Okay, only the difference is what? A comma B you are having instead of only A exactly. Okay, but here in case of B, observe it, length of W mod 3 is not equal to length of W mod 2 exactly. See here, greater than or equal to had. Okay, here we are having not equal to. Okay, case 2. To accept strings of W such that length of W mod 3 not equal to length of W mod 2, where we are having alphabet A comma B, the pair x comma y such that x is not equal to y are the final state. Okay, in the same variety how we solved in the previous question, same thing we need to solve. Okay, see here we need to find the cross product and all. Okay, everything is same. Okay, everything is same. Only difference is what? Deciding the final state will be different. That's it. Okay, so what all the states which are having not equal to condition, see 0011 will be the non-final state. Okay, see here 0011. Okay, will be the non-final state. Apart from that, rest of all will be final state. Why? X and Y should not be equal. That is what the condition. Whether it is greater than or less than does not matter. Clear? Condition is what? X should not be equal to Y. That's it. Okay? Because in previous slide, okay, in this particular slide, okay, case number B or case number 2, observe it. Length of W mod 3 should not be equal to, okay, not equal to length of W mod 2 exactly. Okay, so here x and y combination, okay, should not be equal. 0, 0 equal. So this cannot be a final state. 1, 1 equal. This cannot be a final state. 2, 0, they are not equal. 0, 1, they are not equal. Okay, 1, 0, they are not equal. Then 2, 1, they are not equal. Okay, because of this, so this is what the DFA, what we can design for mod 3 not equal to mod 2 exactly. Okay, okay, students. So we left with one more variety of DFA problem. So in next lecture, we'll discuss about that. So that will be the end of the DFA. So we'll solve few problems of NFA and later we will go for epsilon NFA. Okay, so hopefully that will finish your module number 1. Okay, so it is a bit lengthier. Like in DFA, we are having 4 to 5 different kind of problems available. Fine. Okay, students. So start practicing the problem. Okay. Simply, if you are listening the lecture, it won't work exactly. Okay. In your exam, you want to perform well, you need to practice properly. Okay. Take any different question, get the question from net or else from previous question paper. Fine. Refer the textbook. First, try to learn how different it is, which we are solving in our class. Okay. Try to identify what is the differentiation we are having over there. Okay. Identify it, later try to resolve it. Okay. Okay, students. So we'll wait with next topic. Thank you.